Okay, so we'll start today's session. So, if you recall what was discussed in the last week, uh, what was there? I forgot. Yeah, just we just okay. So in the first week we just discussed about what the optimization problem basically is, and yeah, we solved it graphically for some two variable problems. And, we saw some word problems and how they are modeled using linear programs. So our focus was on linear programs because they are in some sense easy to analyze. And so in the last week's content, we relied on uh, graphical solutions, which is not really scalable beyond two variables or even three. We can't really find the solutions which are the vertices of the polytope, which is made by the constraints of the linear program. And in this week's class, what was covered was the simplex algorithm, and I think some problems were discussed to solve. Like the tableau method was discussed, where you have to draw those tables and find the basic feasible solutions, and then iterate to find the optimal solution. And what are the conditions where you will realize that it's optimal solution? So it's also some work is there. If the number of variables are large, you have to draw very big tables, but these are in some sense computational methods. So you write code for them so that you don't have to worry about drawing these tables again and again. And in practical scenarios, you have softwares available where you just need to write the linear program, and it will uh, perform the simplex for you, and it will give you the solution. Okay, so let's look at this question. You have any doubts? Okay, if there's no question, then I'll continue. So, yeah, so the first step in solving the simplex is like writing it in the standard form, writing your LP in the standard form. So, so this question is basically asking you to write this given linear program in the standard form. And if you recall what is the standard form, it has to be something like max x u transpose x, x equal to b, x greater than equal to 0. This is the standard form. So how will we make this in the standard form? Okay, these are your constraints. Any idea what we should do?
Yeah. Hello.
Yeah.
Actually, I am on the way right now, so I will be. I will call you later after 5 to 10 minutes, please.
Okay. Okay. Yeah. No problem. No problem.
But I am listening.
Okay. Okay. Good. Great. Great. So okay. So one thing you need to do is make all the variables. Uh, they need to be positive. And if you see here, X does not have any constraint that it should be positive, and even Y doesn't have a constraint that it should be positive. It has an upper bound and lower bound. Okay, and okay, L and U are not your variables. The variables you have are only X and Y. So to make like to have positive constraints on these variables, you transform them as X equal to some X plus minus X minus. Okay, similarly you do for Y equal to Y plus Y minus, and you put constraints that X plus X minus Y plus Y minus should be greater than equal to 0. Okay, this looks okay, right? If Y plus is greater than Y minus, you get Y can be negative. Sorry, Y plus is greater than Y minus, then Y will be positive. If Y plus is less than Y minus, then Y will be negative. Okay, so here Y can take positive or negative values, but Y plus and Y minus can only take positive values. Okay, so using this transformation, we you have to substitute X plus and X minus in terms of instead of X and Y all over the place. So now your problem will be in terms of these positive variables. So then what do we get? You will have a1 x plus minus a1 x minus equal to b1, a2 x plus minus a2 x minus plus b2 y plus minus b2 y minus less than equal to b2, and you have y plus minus y minus less than equal to u, and y plus minus y minus greater than equal to L. Okay, now what we need to focus on, now we have all the variables in this thing we have, right? This side. Okay, we have this constraint also. Okay, so here we have our LP in terms of these positive variables, but we need to get rid of this inequality and make them into equality constraints. So if we do that, the first constraint already has an equality, a1 x plus minus x minus equal to b1. The other one we need to change it. So how do we do it? We add a slack variable, and this new variable should also be positive. So a2x plus a2x minus plus b2 y plus b2 y minus plus z is equal to b2, and z is greater than equal to 0. Okay, so this becomes one of our new slack variables, and we'll do same thing for this y plus y minus plus some s is equal to u, and s is greater than equal to 0, and again y plus minus y minus minus s, sorry, minus t is equal to L, and t is also greater than equal to 0. Okay, y plus minus y minus should be greater than L, right? So if I subtract some positive value, t is a positive variable, it should become equal to L. So now this becomes our set of constraints, right? With x plus x minus y plus y minus z s t greater than equal to 0. Okay, so this is in our standard form. You can write the objective also. So basically max x plus y plus x minus y minus s t and z. C transpose C transpose x plus minus C transpose x minus plus D transpose y plus minus D transpose y minus. Okay, this is your objective. Is it? Okay, you can even write it in some matrix kind of form. Mm, even so basically you'll have your variables x plus x minus y plus y minus z s and t. Okay, so a1 x plus minus a1 x minus, and then and these zeros 1 2 3 4 5 5 zeros 1 is equal to b1 and a2 x plus minus a2 x minus plus b2 minus b2 1. Here you have b2 and then you have 0 0 1 minus 1 0 1 0 and u 0 0 1 minus 1 0 0 minus 1 and L, right? Okay, this is your constraint. So here it can be a matrix here of appropriate sizes. Any doubts? Okay, here I think it should be identity because these can be vectors, right? This T, S, Z, all these can be vectors. B1, B2 can be vectors. These can be matrices. So y plus x minus s t u l, these all can be vectors. So you'll have identity. Okay. So there is no doubt in this question, then I'll go to the next. Okay, so write the question. You need to solve this LP using the simplex method. Okay. So as we saw, the first step is make this into the standard form. So if you write the standard form, the objective will stay the same because these variables are already positive. We will add a slack variable, right? So we'll x3 think. That is how it is done in the video lectures. 2x1 plus x2 by 2 plus some x4 is equal to 8, and xi is greater than equal to 0, and let I is 1 2 1 2 3 4. Okay, so we have this in the standard form. And we need to you do the simplex. Okay, so the simplex we need to write the table. We also need to be clear like why are we making the table, what are the entries, and why they are like that. Okay, so if you recall the table, if I am making mistake this correct way, you have the entry cj which has some okay, and you have all the variables here, right? And the basic variables, and the coefficients of the basic variables in the object. for each of these, uh, each of the variable you also compute this quantity equal to zi minus cj. Okay, so first thing that we require is we need to know, as we saw in the graphical solution, the solution of the LP are the corner points. So your constraints, they will make some feasible region which will be change something like this because of some inequalities. Okay, let's say this is, so this is the, these are the inequalities you need to be in this region. Some ax1, like some a1 transpose x equal to, let me say less than equal to b1. Let's say it is like this. Okay, and something. So we saw in the graphical solution part that you just need to look at the vertices uh, to find the optimal solution, like whichever has the lowest objective value, that is our optimal solution. So basically we need to, the simplex also does the same thing. It goes from vertex to vertex, but you need to start with some vertex and then go to the neighboring vertex where the objective value decreases. That is the basic principle in simplex. You start with the vertex and go to a neighboring vertex where your objective value decreases. Okay, so how do we get the first vertex? Okay, which vertex do we start with? How do we find the vertex of the polytope without really plotting it? Any idea? Like if you recall the lecture, what is the first step that you do? What entry do you put in into this simplex, into this table? So if you see here, I'm just rewriting this. There's 0 times x4 equal to 5, 0 times x3 plus x4 equal to 8. Okay, the coefficients of x3 x4 here are 0. So in an n-dimensional space, like in, let's say, let's take 2D. So in 2D, to get a vertex you need two lines, right, which are like two constraints. Like a vertex is made by two constraints. Even if I take out this constraint, I still have that vertex. Similarly, for this vertex, for, the, for this vertex, if I take out this constraint, I still have that vertex. And in 3 dimension, similarly, you need three constraints. So in n dimensions, you will need you need like n. So these are basically hyperplanes, right? N hyperplanes. Get a vertex, and basically it's like this constraint is active here. Like this point is here means if this was, so I said this is a1 x, a1 transpose x less than equal to b1. This is a2 transpose x less than equal to b2. This is a3 transpose x less than equal to b3. Then at this point a1 transpose x is equal to b1, and again talking about this point, and a2 transpose x is equal to b2. But if you look at this thing, so let me call this as x p or something. So xp, what you can say about the third constraint is it will strictly be less than b3, right? So it's far away, and this point passes through these two constraints, so it is equal to. Same thing you can do with the others. So this is the kind of condition that is used to find the first uh, point, and that point, which is a corner point, is called the, if you recall from the lecture, it's called BFS, that is basic feasible solution. Okay. So constraints are basically ax equal to b and x greater than equal to 0, and if x is in Rn, and this A is n cross n. So in n dimensions you need basically n constraints to be active to hit a corner point. Okay, so if x star, if xp is a corner point, then at that point n constraint should be active. Okay, so in whatever we are considering, we basically take m less than equal to n, because if m is greater than n, then there can be some redundant constraints and you can basically remove them and again get back m less than equal to n. And this m so basically this m, you say consider the rank of a is equal to m. So rank of a is equal to m means this a you can basically write as two matrices, that is like b and n, like you shuffle the columns, where this b is like, let write b is m cross n, and this n will be n cross n minus n. Okay, so in this problem what we have is your matrices, a matrix is basically 1 1 1 0 2 1 by 2 0 1. Okay, and what I said is you can split this, and you split this in such a way that this b is singular, Okay, that is rank of B is equal to M. Sorry, it should not that singular, it's non-singular. So this corresponds to your variables, right? X1, x2, x3, x4. And if I'm splitting this A into two matrices B and N, where one is non-singular and it is M cross M, so here it is 2 cross 4, right? So I need a 2 cross 2 matrix which is non-singular, and you can clearly see this identity matrix is there which is non-singular. Okay, so this B becomes like a set of variables. In this case, this B set has 3 and 4, and the N set has 1 and 2, right? 3 4 in the B set, and N has 1 and 2. So it's called uh, basic variable set and non-basic variable set. Okay, and the basic feasible solution is basically something that satisfies it's of the form xb 0, okay, and x b is equal to b inverse small b, where b is the same thing that is here. So the non-basic variables are 0 and the basic variables are uh, b inverse b. So this forms your BFS. Okay, so these are basically, if this is this this will be greater than equal to 0, that is also required. Maybe like this is your BFS, basic variables. Okay, this is because of the greater than equal to constraint that we have. And so basically, if you see, just a second. Okay, sorry, someone just knocked at my door. So yeah, wait. If you have any doubt, just uh, you can just ask me randomly, or you can type in the chat. I'll be monitoring the chat, because this needs some attention, and it's quite important also that you understand, so that you don't make mistakes when you're solving it. If it's clear like what is what, then you won't make mistakes when you're solving it. Okay, so if these xb's are positive, let's say, then these other constraints are equal to 0, right? So this other constraints meaning uh, these n minus m variables, they are equal to 0, and these m variables, they are positive. But to get a corner point, you in n dimension you need n hyperplanes to intersect, like n constraints should be active. So now only n minus m are active, but Remember that all these always satisfy this, and these are m constraints. So n minus m from this you get because of the equal to 0, and plus m constraints will be active because of ax equal to b. So this is from xn equal to xn is the non-basic variable. This is 0, and this is because of ax equal to b is satisfied by both xb and xn. So together this xb 0 becomes a corner point. Okay, so this bfs will be a corner point. Okay, so like having this in mind, we can try to do this. So if you recall what needs to be entered in these rows, here you have the coefficients, what you have here basically 1 1 1 0, 2 1 by 2 0 1, and b is 5 8, which is basically this, and xb will be your basic variables which correspond to the non-singular submatrix. Okay. So your basic variables are x3 and x4. And the cb is basically the coefficients of these basic variables in the objective, which is 0 0. Now the next step that you do is you compute this value zi minus cj. Okay. Now why you need to do that is just look at my notes on. Yeah. So I don't know if I should do the derivation or not, because it's already done in the video lectures. But uh, get some, like your objective function, which is z equal to c transpose x. You write it in terms of your basic and non-basic variables again, xb xn. Okay, and that somehow comes out as cb b inverse b minus j in j. Okay, and like I'm not going through the whole derivation, I'm just telling you what comes out. But to look at the derivation, you can see the lecture. I hope you have seen it. Okay, where this j is basically uh, indices of non-basic variables Okay, so this is your objective function. This b inverse b is basically this xb, right? So in this case, j will contain in the first iteration where our basic variables are 3, 4, and non-basic are 1, 2. So j will contain 1 and 2, and this a is the jth, like aj is you can say jth column of this A matrix. Okay. So for this, what you do is you're starting with one corner point, and you need to see if like you need to go to the next corner point and see if your objective value increases or decreases. Okay. So go to the next corner point. Some variable has to come to the basic uh, set, and some basic variable has to go to the non-basic variable set. Okay. So when this transition happens, you again get n constraints active, and you get a corner point, a different corner point basically. Okay. So which variable should come to the basic and which variable should go to the non-basic? To decide that, you look at the derivative of this with respect to one of the non-basic variables. Remember, j is the indices of non-basic variables. So if you do that, what you basically get is this thing, because it's derivative with respect to aj, like xj. And this term in the lectures, it is referred to as zj, like not to be confused with this z, but this is also called zj. Okay. So this is the derivative of z with respect to xj. So we will want to bring this non-basic variables, which in our current solution are 0, right? We set the non-basic variables to 0. So if I'm bringing them to the basic, that means I have to increase this xj and decrease the basic variables to 0, one of the basic variable. So if I'm increasing xj, by increasing which xj uh, will I get the most increase in z, that we'll look at via this derivative. Okay. So if you want this to be positive, that means your zj minus cj should be negative, right? So the most increase will be for the value which has the most negative value of j minus cj. Okay. So this is the reason why we compute the zj minus cj. And like you may want to recall that the b that we have, b is identity, right? That is how we have constructed our b. B is identity and non-singular. So this is basically zj is basically just, because b inverse will still be identity, it's basically cb into aj, right? Ages we have already written here. These are the ages A1, A2, A3, A4. So Z1 will be CB into dot product of basically CB and A1, that is 0, minus CJ, that is 4. This is minus 4. Okay. Because this is 0 here, CB into A1 is 0, CB into A2 is also 0, 0 minus CJ is minus 2, and this will be 0, 0. So the most negative value that we get is minus 4. Okay, so this is what is called the entering variable. Okay, this variable will go from non-basic, because x1 is non-basic, it will go to the basic set. Okay, and we also need to take out one variable from the basic set and bring it to the non-basic. Okay, so we have to choose between x3 and x4. So to do that, we look at another value. Okay, so let's say you get xk. Okay, let xk, let me just increase the size of this page. Mm, so let this xk be the entering variable. Okay, now you can write the basic variable in terms of the entering variable, basically b inverse b minus b inverse ak xk. I think we have written it somewhere. Okay, we haven't written it, but you can find in the lecture, you get this term. And recall that all your variables should be greater than equal to 0. So this xk, you will be increasing from 0 to some positive value. Okay, so yeah, so uh, what you okay, one thing you may want to see is this is a vector and this is a scalar. So this is one variable. Mm, this is one dimensional variable. Okay, this is a vector and this is also a vector. This is a identity matrix in our case at least. So you want to choose which of in this vector has a set of basic variables, right? For example, in our case, the basic variables are x3 and x4.
Hello.
Yeah.
I think that B inverse should not be there. Xb is equal to B inverse B minus that B inverse should not be there. Like it will be AK XK, I think. Because in the notes it was in the lectures it was there.
Mm, are you sure?
Yes. Because the value of dou XB upon dou XK equal to minus B inverse AK, that we have taken equal to minus of alpha K. In the lectures it was taken. I have written it, that's why I'm
Can you repeat what?
dou XB upon dou XK. equal to minus b inverse ak into ak equal to minus of alpha k.
Hmm.
There, therefore, xb is equal to b inverse b minus xk alpha k minus xk alpha k.
So this is the same thing, right? Alpha k is basically B inverse AK. So that is
Okay,
B inverse.
alpha k is b inverse ak, right?
Yeah, yeah.
Okay, okay, you have written ak. Fine, fine, fine. Yeah. I thought it was alpha k.
Yeah. So what I was saying was you have these basic variables, that is x3, x4, and you want to find which one should go to the non-basic set from the basic set. So this xk is what you determine to be the entering variable that will go to the basic from the non-basic set. So the non-basic set variables are set to 0 and you have to increase them. And for these two, what you'll get is B inverse B, which will be a vector, and you will take the first B inverse B second, okay, minus B inverse A case first entry times xk, and B inverse A case second entry times xk. So as you increase xk, one of them will become 0 first. Okay, currently both are greater than 0, greater than equal to 0. So as you increase xk, one of them will become 0 first. And which one will be 0 first? That you will determine by looking at the ratio B inverse B by uh, what you are written here as alpha k. Okay, look at this ratio. So this is because B, this is identity. I think it should be alpha I k. What I am writing is B inverse A k ratio of these quantities. I. Okay, so alpha I k is equal to B inverse A case ith entry. And because B inverse is basically identity only, so what you'll have is Bi upon uh, this will also be identity A k I or something, or A I k. Okay, so I think it is A k I, na? A k, no, A I k. I is the row and k is the column. So here if you see, if you look at, if you want to compute the ratio, that B B by Bi by Aik, and B is 5, and this is K is 1, we got. So 5 by 1 and 8 by 2, that is 4. Okay, and the minimum here is this. So if you increase like x4 will hit 0 first when you increase x1. That is what we understand by this. Okay, so this is what we call as the pivot. Now what we need to do is you'll write this tableau again. I think I'll have to extend this again. So let me copy this. So most of the things will be similar, like this CV thing we again have to use. So let me just extend this. Okay, so now our basic variable has changed. It is x3 and x1, right? And yeah, so what do we do with this pivot? Because this is these basic variables have changed, now we have to modify our A matrix in the sense this B, and remember we made A equal to B and N, and what made us think simple here was B was equal to identity. Okay, B is identity, that's why B inverse identity we don't need to compute. So we'll try to maintain that to maintain that this B remains, even though we are changing the variables of B. Every time we change, we again try to make the B identity, so then B inverse is also identity. So to do that, we make this row uh, such that this entry is 1. Okay, so to make that 1, we divided it by 4. So basically, if you have some inequality a1x a1 transpose x equal to b1, even if you divide it by some value, constraint is still the same. So you divide it by 2, and what you will get is 4 1 1 by 4 0 1 by 2. Okay, and we make this one 0. Okay, if you have to make this 0, what you will do is this row 1, you will do row 1 minus row 2 divided by 2, right? So 5 minus 8 by 2 is 5 minus 4, that is 1. This will be 0. So this will be 3 by 4. This will be 1. This half. And this CB is the coefficient of x3 and x4, sorry, x3 and x1, which is 0 and 4. Again you have to do the other computation. Z minus CG. So if you see, again we have like x1 and x3 are our basic variables, and x1 and x3, and they are forming an identity matrix. Okay, that's why we made this one and this 0. If we had made this one and this 0, that wouldn't happen. We made this one and that 0, and we did r1 minus, like, I could have done r1 minus r1 also. That also would have made this 0, but then you lose this. Okay, and that constraint will vanish in some sense if I do this. So that doesn't make sense. Another thing I could have done is 2 times r1 minus r2. Okay, that would also make this 0, but that will make this 2. So then it's not identity matrix, and this constraint will be valid constraint, because we wanted identity. I did r1 minus r2 by 2. Okay, so we repeat this zi minus cj equals zi is, okay, I forgot, zi is I think cb, whatever, zi is cb times ai. So that is, so z1 is 4, and zi minus cj is 4 minus 4, that is 0. Z2 minus C2 is 1 minus 2 minus 1. This will be 0. This will be 2. Okay. So the most negative is this one. Right. This is your, give some color. Okay, in first case it was this. Now this. I need to find the leaving basic variable from x3 x1. To do that I need to compute this value, which is bi 1, bi is what, 1 divided by 3 by 4, which is 4 by 3. And this is 4 divided by 1 by 4 is 16. Okay, so you get this. So x3 is your, x3 is the outgoing variable, and x2 is the entering variable. So we do this again. So when you end this is when zi minus cj is greater than equal to 0 for all j. Okay, the reason, as we discussed, is this gives me, like, by changing the non-basic variable, how much I'll gain in the objective. So if it's positive for everyone means I won't gain, because negative or positive means I won't gain if I change the basic variable. Okay, so we need to keep doing it till we hit this condition. So x3 is outgoing, x2 is incoming, so I wrote x2, x1, and I need to rewrite this again so that this is 1 and this is 0. Make this 1, I simply divide by 4 by 3. Make 4 by 3, 0, 1, 4 by 3 minus 2 by 3. And to make this 0, I'll do r2 minus r1 by 3. So this will be 11 by 3, mm, 1, 0. This 1 by 2, 1 by 6, right? Now I need to look at zi minus cz. So this will be 4 minus 4, 0, 2 minus 2, 0, by 3, by 3 minus 4 by 3 is 4 by 3. Okay, so this condition is now met. Zi minus cz is greater than equal to 4 always. So this is our solution. That is x1 equal to 11 by 3, x2 equal to 4 by 3, x3 equals to x4 equal to 0. So I think originally the objective is only in terms of x1, x2. So we just need to substitute x1, x2, right? So one thing I didn't write, I think this is, we change this also to max. Max, I think doesn't mean we change it to max. That's why we have 4 2 instead of minus 4 minus 2. Okay. Any doubts? I hope you were able to follow some things at least. Otherwise, you can relook at the video also and you can just ask some doubt now if you are not able to follow something.
Yeah, it's good. I have something to ask.
Yeah.
Not regarding this,
Okay.
but regarding assignments. I will not ask questions, but
Uh,
I have some queries.
okay.
Okay, like for one is that in assignment two,
Uh,
in one question, the all the options are not matching with my answer, and
okay.
I have solved with multiple methods like
Mm-hmm.
graphical and simplex as well.
Mm-hmm.
And in both the cases, I am getting a answer
Mm-hmm.
which is different from all the four answers, and I am getting the same answer.
Okay. Okay.
And in this situation, what should I do? I should leave the question, or I should attempt any one option. I should click any one option, whatever or
Uh,
that.
what you can do is you can post it in the discussion forum. You post this thing that this question is there, and
Oh, okay. Your voice is cutting.
oh, sorry. So what I'm saying is, in the discussion forum, you post this thing that in assignment to question number this, I whatever solution is that also you post and say like
Yeah.
this is not matching. Please look into it.
Okay.
So then that question will automatically be discarded.
Okay. And in the same assignment two, there are two questions like question number 5 or 6. They are the
Uh-huh.
same.
Oh,
Means they are same. Question number 5 and question number 6 are same.
okay. Then, but the correct answer is there in that.
Yeah, correct answer is there. So
Okay.
I have attempted.
Okay.
Means this is a printing error from that side.
Yeah, that could be possible. I think there is some some students are there who create these questions, and then some randomly they are selected and put in the assignment
Yeah,
every
okay,
semester.
that's fine. But in the evaluation process, either these two questions have to be eliminated, or like don't.
Yeah, yeah,
If it is a software, then it will like, automatic take any two
yeah,
option, whatever it will be, true for question number 6 or question number 7, right?
yeah, yeah. So just write these things
That
in the
one.
discussion forum so that there is a TA who has to look into this. So he will look into
Okay,
this.
discussion forum link. Where I get?
In the website itself for the course, you will get like ask a question or something is there at the top.
Okay, okay, fine,
If you click that,
fine,
it
fine.
will take you to the. It's a Google group where you can post it.
Okay, okay, okay. I will check. Thank you.
Yeah. Okay. So yeah. So this what we discussed was the simplex method basically, which you perform using this Tableau method. You make this table. You put all these entries. You start with the feasible set of variables. You find the entering variable and the outgoing variable, change the basic variable and the non-basic variable set, and then basically there's an exchange of the variables from one set to the other, and you do this till you have the condition that these values that you're computing in every table, zi minus cj, they should be greater than equal to 0. Okay, so you need to just be careful about what these values are. Once you're clear about why we use these values, I think you won't have much trouble. So let me look at some other question. Okay. So we have some LP, and they're asking us verify that the choice b equal to 1 2 and n equal to 3 gives a basic feasible solution and hence solve the problem. How will we do this?
Like b equal to 1 to what does it mean?
Basically, your basic variable set has the variables x1 x2,
x1 x2, right?
and non-basic variable has 3
Achha,
x3.
then x1 equal to 1 and x2 equal to 2.
No, it's not x1 equal to 1 and x1 equal to 2.
Then
It is saying that the basic variable set has the variables x1 and x2, and the non-basic variable set has x3.
okay, so x1 it can be, x2 it can be, yeah, it can be.
Sorry.
Yeah, it for basic variable identity matrix has to be there.
So xb is the vector x1 comma x2, and xn vector is x3. That is what this means. Okay.
Yes.
So what is the property of the basic feasible solution?
X1 x2 has to satisfy the like b has to be a invertible matrix,
Hmm.
and non-basic variable has to be 0.
Hmm.
For x1 x2 is basic, it's 3 1 and 1 minus 1, 3 1 1 minus 1. Yeah, it can be.
So basically, if you put xn equal to 0,
Yeah.
that is x3 equal to 0.
Because it will have rank, the A matrix will have rank 2, right?
Yeah.
So rank 2 means basic variables, there will be two variables in the basic solution.
Yeah. So b will be.
And I think 3C2 equal to 3 basic solutions will be there. So x1 x2 x2 x3 and x2 x3, it can be a basic solution.
Yeah. So basic feasible solution means.
It also satisfies the non-negative restrictions.
Yeah.
Basic solution satisfies non-negative restrictions.
So then we just substitute 0 here, and we can compute the value of x1 and x2, right, to see if.
Yes. 4x1 equal to 4, x1 has to be 1. If x1 is 1, then x2 is 8. 1 8, x1 equal to 1, x2 equal to 8, x3 equal to 0.
Equal
No,
to.
not x1 equal to 1, then x2 equal to minus x2 equal to 9. 190.
Yeah, this looks correct. This is a this is a basic feasible solution, right? And to solve this, what do we do?
Okay. First we convert this in maximization problem, and then use simplex method and take a initial basic feasible solution as x1. No, that will be artificial variable added. Then we can take.
Mm,
We use begin method here, right?
you need not actually.
Uh, why?
We can convert this, right? So that some 1 0 1 0 you get here, something like that.
Okay, then
Or maybe I should get it here. Then
this is. Mhm.
so you have 3x1 plus x2 plus equal to 12, right?
Yeah.
So let's say I create basically you have this 3 1 1 1 minus 1 1 12 minus. So I can just transform so that this is uh, how to say
A Galen
identity
form.
max. Yeah.
Okay. Okay.
So we can do this 4 0 2. So I'll do R1 equal to R1 minus 3 by 4 R2, right?
Hmm. Either you can take R2 tending to R2 by 2, then R1 tending to R1 minus R2. That
Sorry,
will be easy. That will be easy calculation.
what are you saying?
R2 tending to R2 by 2,
Ah, okay, okay.
then 2 0 1 2, then R1 tending to R1 minus R2.
R1 minus R2. That won't help, right?
But that will create 0 there
Yeah, yeah.
in the opposite. We are making 2 as 0.
No, we need to make 3 as 0.
3 as 0.
So I'll do R1 minus 3 by 2, right? So I'll get 3 minus 3, that is 0. This will be 1 only. This will be 1 minus 3 by 2. This will be 12 minus
12
3 by
minus 2.
2. And this I can divide by 2. 24 minus 6 is how much? 18.
9.
Sorry?
That is 6 by 2, right? So it will be
Ah,
3.
9.
12 minus 3 is 9.
Yeah, yeah, correct, correct. So now I need to make the table and copy it from here. So I have only three variables, right? So I don't need anything. So 4, 2, 2, and basic variables are x2 and x1. Mm, no, sorry. This should be one, right? So zi minus zj minus cj will be 4 minus 4 0, 2 minus 2 0, and this is 2 plus 1 3 minus 2. That is what, right? 2 minus 1 1 minus 2 is minus 1. So that means this we need to change. So we compute the other value, which is ba by a I k. So what do you get? Minus there's a condition where you don't really choose this. That was discussed, right?
Yes,
So why was that? Uh,
at what, look, in the departing variable,
yeah,
if it is negative or it is in being infinity, then we cannot choose it. It has to be greater than equal to 0.
yeah. And the
Because all the BIs are greater than 0 and all the AIs. This is not BI. BI.
yeah, basically, if we increase, the value becomes negative, right?
Yes, yes.
That's why we don't do that.
Yes.
Basically, if I increase this, then the basic variable value, instead of decreasing, it will start increasing. But we want, if we increase the basic variable value, should go to 0.
Yes, yes. Otherwise, it may become unbounded.
So if our calculation everything is correct, then we should be pivoting on this, right? So that means instead of x1 you get x3, x2. Someone is saying are you hearing something? No, right? There is
No,
something
no,
background noise coming in my hostel.
no, it's fine. There is no background noise.
Okay, so yes, so this will be 2, 2. We need to make this 1. To make this one, we multiply it by 2, right? 2, 2, 0, 1. And to make this 0, we just add this to it. So this is 0, 1, 1, 1 plus 9 is 10. So what do we get here? 4 plus 2, 6 minus 4 is 2. 2 minus 2 is 0. And here also 2 minus 2 is 0. Okay, this is cancelled. So you get x2 equal to 10, x3 equal to 2, and x1 equal to 0. Okay. So 10 and 2, if I put into this, x1 is 0, x3 is 10, 20 plus 24. So in this I'll get objective as 24. What would I have got if I had used this? x3 is 0, is 18 plus 4, that is 22. No? Okay, that would have been 22. So this is more. So this is okay. Okay. So there's no doubt, right?
Yeah, it's okay.
Okay, so consider the LP problem of question 8.1. Okay, 8.1 is basically previous question. Okay, these questions I have taken from this book called Roger Fletcher. So these are questions which are at the back of that book. So consider LP problem of the previous question. So let me just copy it.
What was the last table
Sorry,
in this problem? The last table, what was it?
last table.
Yeah, last simplex table.
This,
Yeah, 200
yeah,
ZJ minus AJ. But here x2 and x3 are basic and x1 is non-basic, right?
yeah.
So non-basic is greater than 0. It has to be a unique solution.
What are you saying?
Because we have studied that if Zj minus Cj is greater than 0 for non-basic variable,
Yeah,
then the problem will have unique solution.
yeah,
Yeah, that's why if this is the table, then this problem will have unique solution, right?
yeah, yeah,
But and in that question, constraints are same. But okay, fine. Objective questions, objective function is changed, right?
yeah, yeah. Objective is different.
Objective is different. I think. Okay, fine. Okay, then that will be a calculative problem.
So LP from previous question. So modified will be, let's say, max 4x1 plus 2x3 subject to. So they are saying show that the basic physical solution derived from are both optimal.
Okay, so we have to check in the simplex table that the Zj minus Cj is 0 for some non-basic variable.
Hmm.
Then it will have an infinite solutions. Like if there are two solutions, then it will have infinite solution because every convex combination will also have a solution. Will also be a solution.
So you can just take the table from here. This is 0, right? So I need to change this. This is what you get, right? is for b equal to 1, 2, n equal to 3. And if I choose these as my basic variables, x2, x3, then this will automatically come out like this only, because this is just the manipulation of the constraint, and 2, 3 are forming the identity basic thing. 2 has is 0 is 3. So what do I have? 2 minus 4, this is 0, minus 2, right? This is not coming out. Am I doing something wrong?
What?
Here I'm getting negative.
Maybe this is not the optimal solution. We have to iterate one more time because I am not following the calculations.
What I am saying is, they're saying the basic feasible solution derived from b 1 to n equal to 3 and b 2, 3 n equal to 1 are both optimal.
Yeah.
That means for both the set I should get a greater than 0, right?
Okay, but maybe in the second table we will not get. In the next iteration we will get, because here we will entering variable will be -2 if it is most negative, right?
Uh,
Maybe iterations will be more here, not only two.
but I got this. I'm using this as the non-basic, like the basic variable set.
X2 and X3, right?
Yeah.
Okay. Maybe something wrong. It will. Yeah.
Oh no, I wrote incorrectly. Sorry, this is not minus 2.
2 2 is 4 -4, that will be 0, right?
0. Why did I write minus 2? I don't know.
Okay. Maybe you have miscalculated with 9, but it will be
Oh, I was
-7.
looking at this 0. I was like, something I did.
Okay, 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 fine.
This is also 0. This is also 0. So now it makes sense. This is
Yeah.
n equal to 1. So both are optimal.
But yeah, non-basic it is 0, so it will not be a unique solution.
Yeah. So that is what they are. How do you recognize that as a non-unique solution? If
For non-basic, Zj minus Cj is 0 for non-basic variable.
then non-unique. How do you show the convex combination of these solutions also solution to the problem?
You can take two solutions, then take lambda times x1 plus 1 minus lambda times x2, and so and it will also satisfy the same things for lambda belongs to 0 and 1.
Yeah. So if x and y are the two solutions,
Mm,
then lambda x plus 1 minus lambda y.
has to be a,
This will also satisfy the constraint.
yes.
Basically, also be equal to b, and
Yeah.
c c transpose lambda x plus 1 minus lambda y is equal to c transpose is equal to c. This is very easy to see.
Yeah.
Lambda y 0. Okay, now we will do this.
Mod of x1 minus 2 less than equal to 1.
Hmm.
Okay, then these are two constants, right? Combining in one.
Yeah. So this we can.
So x1 has to x1 less than equal to 3 and x1 greater than equal to minus 1 plus 2 1. X1 less than equal to 3 1 constant.
This will write it x1 less than equal to 3 and
Less than equal to 3 and x1 and greater than equal to 1.
so what will be
Now we will add slack, surplus and artificial variables. X1 plus x4 equal to 3. X1 minus x5 plus x6 equal to 1.
your objective will have
X2 minus 5x6 m times. Why I'm saying 5. Yeah.
so this m is some value
Very.
very big, so that it forces this x6 to become 0. This is also there, right? So to solve this we do the same procedure, I think. Yeah, that is clear.
Yeah, it will follow the same procedure as previous one.
This is also same thing, just it's about the artificial variable which is this x6.
Yes.
So like even if we don't take include x6, the constraints, the equality constraint still holds. But this we are adding this x6 for convenience of doing the simplex, right?
Yes, 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 yes. Because x1 equal to 1 will become an identity matrix. No, no, it will not become. We have to add x6, right?
Yeah.
Yeah. Otherwise, x1 will not give identity matrix if I will take x1 equal to 1.
Yeah. So if we don't have x6, then our matrix will be 2 3 1 1 0. This is with x1 x2 x3 x4 x5. Let's add x6.
Hmm.
This 1 0 0 1 0 1 0 0 0 minus 1. This is what it will get.
Yes. But we need x6 also, right?
But I think in this case, without x6 also you can do it, right? It will still you will get.
No, how?
You can take this as a
No, this is -1, right?
just multiply it by -1.
Then b will be negative.
Ah, yeah, b will be negative. Correct. We don't want b to be negative.
That's why we have to take x6.
Then we have to take x6. So if we take x6, cancels out 0, 0, 0, 1, 0, 0, 1, 0, 0. So take this,
x3,
this, and this.
x4 and x6.
So this is also like this. These are independent, but because it's not identity, it will just make our uh, we are not really like when we're doing the table method, we are not computing b inverse because we have it as identity.
Yes. This has to be changed first into maximization problem, then we can solve it
This is
as
minus
previously.
x1 minus x2 minus x3 plus 2x4
Plus 2x4
4.
plus x5
So I
plus x6.
think I need to do minus out here.
Ah, we have to make b positive.
2, 2. You're asking is the inequality constraint active at the solution?
What does it mean?
What do you mean by constraint is active? You are asking.
Yes,
Hmm. Constraint is active means
it is not redundant.
no, no. So if you have a constraint a1 x less than equal to b1, and if you ask is this constraint active at some point x star, that means is a1 x star equal to b1. If it is equal to b1, then it is active.
Okay.
If
Means
it's
equality should be there.
uh,
Okay.
if it is less than b1, it is inactive. It is satisfied but inactive.
Okay.
So
First we have to find the solution. Mean at the solution means initial basic feasible solution or optimal solution.
think optimal solution.
Okay, then we have to do
No, I
calculations like,
think find a basic physio solution for. I think at a BFS. Only
okay.
at a BFS.
Okay, so BFS is our x5 is equal to 8 and x6 is equal to 2. So, and all will be 0.
Hmm.
Then inequality constant 8 x5 is not there, right?
Not active.
It is not active because all the 0, 0, 0 is less than 8, right?
Yeah.
Yeah, it is not active. Okay.
So not active at box. Constraint not active. Let me just look at this question also. Okay. How will you do this?
First, we have to change XYZ to restricted one
Yeah, but the
because
objective is also there.
but objective mod X mod Y mod Z. Okay, we can find the solution and we will take the positive values. First, we
Mm.
change it to maximize problem.
How will you change it to maximize? Just minus of it.
Minus of mod X, minus of mod Y, minus of Z. It will be correct or not? But I think that will be same
No,
because
this is different, right?
no, because we are taking minus of fx, right?
Mm.
If maximum z is fx and then minimum z is minus of fx.
Yeah. So
So
this is
okay,
correct, right?
yeah, this will be correct. Minus mod x minus mod y minus mod z, and we will solve the solution. Then we can take the values.
What value will you take?
What values for x? We will get this x y z values, right,
From what?
from simplex table.
What is the objective?
Minimize.
No, what is the objective function? What is the in the simplex table you need to specify C, right?
Okay. Fine. So we will define it like x greater than 0, y greater than 0, z greater than 0. There will
Uh,
be two objective functions.
so for each you will solve it separately.
Uh, but can we place here like if x is unrestricted in sign, then we will have to substitute it by x prime minus x double prime, right?
Yeah, you mean these things.
Okay, x plus x minus, right?
Hmm.
And x plus or x minus will be greater than equal to 0.
What does it mean?
Then
You
max,
substitute x equal to
yeah,
x
minus of
plus.
mod of,
This is what you substitute, right?
yeah. So we can put this value in the objective function as well.
Now,
There again there will be a lot of cases, right? Mm, I don't know.
For this, what you have to do is set it as max of some t, I think. And mm, wait, if I write this as minimize t equal to so 2x is then equal to t1. Yeah, this can be done, right? You understood?
Yeah, it's fine.
So basically, what you need to do is you can rewrite this as log of t1 plus t2 plus t3. Hmm?
Okay.
And t1, t2, t3 are greater than equal to 0.
Okay.
Your x is between,
T minus T1 to T1.
yeah, y is, and then there it is. And you have the other constraints also. X minus 2y plus 3. You will have to do, you can put these things.
Okay, we will add inequalities here. So we will get four constraints, right?
Which four you are saying?
For x minus 2y, if we will add, like in the second constraint, we will multiply by 2 minus 2, and then we'll add x minus 2y equal to 3, right? But if we'll put that x minus 2y lies between minus t1 plus 2t and less than equal to t1 plus 2t 2t2, right? So there will be two constraints from one constraint, another two from other last one. So there will be four constraints, right?
I'm not getting what you're saying.
Okay, I am saying that x minus 2y equal to 3,
Yeah, yeah, this one.
one constant. So for getting the value of x minus 2y, we will add above two inequalities. X is less than uh, equal to t1, that inequality, right?
This one.
Yeah, this one and the middle one.
Why do you want to do that?
Because x minus 2y value we have to calculate, right?
That's a constraint, right?
Yeah, that's the constraint.
Let it be.
Then in the second, in the second constraint,
Uh-huh. Second one mean this one.
minus t2 less than y less than t2.
Oh,
Not
this
that
one.
one.
This one.
This one.
Huh.
We will multiply it by minus 2, right?
Why?
So that minus 2y we will get. Then we will add to the first one, x minus 2y.
But why are we doing
We
this?
we we we, we want constraints in the terms of t1 and t2, right?
No, constraints will x and y everything will be there, right? We know
But
now we to change this.
minimization problem has been changed to t1, t2, t3. Now our decision variables are t1, t2, t3, right?
Plus x y z.
What?
T1, T2, T3 and x y z, right?
XYZ, why XYZ should be there? I'm not getting.
Because
Because
they
we can eliminate XYZ by T1, T2, T3, right?
you can eliminate x y z by T1, T2, T3. That I'm not sure.
Okay, right, just write uh, minus 2T2
Minus 2 T2. Oh, you are
less
saying
than,
ultimately this will be equal to x y z T1, T2, T3. So no, they won't
yeah,
be equal. Uh,
okay. Because I am making minus 2y in the second term, then I will add x minus 2y, like these two inequalities will be added, right?
but I think the easier thing will be just make this x equal to x plus x minus y equal to y plus y minus. Just put it here, 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 here. So you have all
Okay.
variables in positive, right?
Yes.
So basically it will be
Okay.
minus t1 x plus x minus less than t minus t2 y plus y minus less than minus t3 and yes, sorry x plus. So all these will be x plus x minus t1 t2 t3 all are written there, right?
But the constraint, how we will get, like
Which constraint is here?
the above three, how we will write in the matrix form, like x plus minus x minus t1 less than equal to 0.
Yeah,
Yeah,
it will be
like
two
it will.
constraints here from here, two constraints from here, two from here, two from here.
Okay, now it in the above three it will be x minus equal to 0.
This one,
Yeah,
this
the
one you
first,
mean?
no, minus t1 less than equal to x plus minus x minus less than equal to t1, the first one,
This one you're saying.
right? Yeah, this one, what value it will take. I am saying that this will be mod x plus minus x minus is less than equal to 0, right? Mod x plus minus mod x minus t1.
Where is mod is not here, right?
If t1 I will minus t1, if we will add t1 here, right? Then
Hmm.
the left hand side will be 0
You're
plus t1
saying
plus t.
0 less
Okay, okay,
than.
fine, fine. Okay, okay. Now it will be mod of x plus minus x minus less than equal to t1, right? What is the value of first constant? I'm just tell me. Means I'm asking.
Value of first constant.
Yeah. Means how we will write first constant in the terms of x plus x minus t1.
You can write it like this. There will be two constraints in this.
0 is less than equal to x prime. Okay, we will take two constants, right? Okay, fine.
Uh,
Fine. I'm just confused.
like in the first thing we had an upper bound, lower bound kind of thing.
Yeah, we have done it earlier, right?
Yeah.
Yeah, fine. Okay, I think it's 8:15 right now.
Yeah, yeah. This one, I think if you solve it, it will be very lengthy, so I'll skip.
Okay, we will discuss it later. That one was a tricky question.
This you have to identify.
Okay,
Okay. So if you
okay,
have any doubts, you post it in the discussion forum,
okay.
and we'll meet again next week.
Okay. Thank you.
Yeah.